Bismillah ar-Rahman ar-Rahim. This is teacher Iman al-Khaldi explaining from chapter 7, integration. Section 7-5, integration of partial fractions. In this section, you will integrate rational functions. Rational functions means it has numerator and denominator, in which the numerator is not the derivative of the denominator. Because if the numerator is the derivative of the denominator, like we studied before, that means it is the derivative of ln the denominator. Let me repeat it. We said that if the numerator is the derivative of the denominator, that will make it an integration of ln the denominator inside absolute value. But today, our lesson is talking about if the numerator is not the derivative of the denominator. In that case, we are going to classify these functions as follows. We're going to talk about them as two type of rational functions. The first type is if it is a proper fraction. Proper fractions like when we have x over x squared minus 1. That means the degree of the numerator is less than the degree of the denominator. And the denominator can be expressed into linear factors. That means you are going to factorize the denominator to linear factors. The second way or the second form is the improper fractions. That means, for example, if you have x cubed up over x squared minus 1, that means the degree of the numerator is greater than or equal to the degree of the denominator. We will divide in that case to get a polynomial plus a fraction, which can be integrated as before, like the ways that you integrated before in the basic rules of integration. Now we are going to have some examples. The first example is find the integration of x squared over x squared minus 1 times x minus 2. Here you can see that you have a partial fraction and the numerator, its power is 2 and the degree of the denominator is 3. After you multiply this x by this x squared, it become x cubed. That means the whole fraction is a proper. Now, how to integrate such thing like that? We have to check first of all that the numerator is not a derivative of the denominator. Actually, it is not. So here first, we factorize the denominator as the following. Here, this x squared minus 1 is different between two squares. So we can write it as x minus 1 and x plus 1 and keep x minus 2 because it is factorized already. And we can now think about how to find the values of a, b, and c, which can be written in that way. We can see that the whole fraction, the whole proper fraction, which is x squared over x squared minus 1 and x minus 2, can be split like that. X minus 1 in one fraction and x plus 1 in the other fraction and x minus 2 in the third fraction. But we don't know actually how much the numerator should be. Because of that, we consider them by letters like A, B, or C. Now the next step, we need to find them. We need to calculate how much is A and B and C by equaling the numerator. This a should be multiplied by the other factors like x plus 1 and x minus 2, exactly like that. A plus b, and we're going to keep it b and multiply it by the other factors like x minus 1 and x minus 2, plus again c, and we're going to multiply it by the other two factors which are x minus 1 and x plus 1. And that all is still divided by the LCM of the denominator, which are the product of all factors, which is x minus 1 and x plus 1 and x minus 2. You can see that this one or this side is similar to that one. So can we cancel them? Yes, we will. But now what do we have? You have the numerator from the left side is equal to the numerator from the right side. Please, it is better for you to do not expand the right side. That will make your work harder and longer. But you can cancel two of the letters to get that third. And you can cancel next other two to get that second. Or you can cancel A and B to get C. How this can happen? You can do it by finding the value of the constant by substituting x by the zeros of the denominator. So when this denominator can be 0, when x is equals to 1. So we are going to start by considering the first 0, which is let x equals 1. And then we're going to replace it everywhere. We're going to place it in the first numerator and equal it by the next or the other side of the numerators. That will make it exactly 1 square equals a bracket 1 plus 1 multiplied by 1 minus 2 plus b multiplied by 1 minus 1 times 1 minus 2 plus c times 1 minus 1 and 1 plus 1. You can see that we replace equals 1 in each x in the numerators. Now you can see that this b gonna be cancelled because it is multiplied by 0. And this c gonna be cancelled because we multiplied by 0. And what is left? We have a only. Let's evaluate its value. Now it is 1 plus 1, which is 2, times negative 1 from this bracket, and multiply them, you will get negative 2. Then you can divide both sides by negative 2, and you will get a equals to negative 1 over 2. Similar, you can find b by canceling a and c. So let us see when the denominator of b can be equal to 0. If x equals to negative 1. So you can let now x again equals negative 1, then substitute instead of each x. Exactly like that. Be sure to make negative 1 inside a bracket because if you didn't, you will do mistakes. Negative 1 to the power of 2 will be positive because negative 1 times negative 1 is positive. And that all will give you a times negative 1 plus 1, negative 1, negative 2, plus b times negative 1, negative 1, and times negative 1, negative 2, plus c times a bracket negative 1, negative 1, and negative 1 plus 1. This c going to be cancelled because here we have 0. This A going to be cancelled because here we have 0. So what is left? B is left. How to find it? We will have from the left side 1 equals 2. Let's calculate it. This will give you negative 2. And this is negative 3. Negative by negative is positive. 2 by 3 is 6. B and B can be equals by dividing both sides by 6. 1 over 6. Now we need to find C. To find C, we're going to cancel A and B by thinking about the number will make the denominator equal to 0, which is 2. So let x equals 2, then we can say that 2 squared equals 2. A times 2 plus 1, 2 minus 2 plus b times 2 minus 1 times 2 minus 2 plus c times 2 minus 1 times 2 plus 1. You can see that because here we have 0, b going to be cancelled. And 2 minus a 2 because if it is 0, so a going to be cancelled. What is left? C is left. Now let's evaluate it. It is here 2 minus 1 is 1 and 2 plus 1 is a 3. 3 times 1 is a 3. From the other side, 2 to the power of 2 means 2 times 2, which is 4. And that means you can make C by or get C by dividing both sides by 3, and you will get 4 over 3. Now we are going to replace A, which is negative half, here instead of A in the numerator, and 1 over 6 here instead of B in the numerator, the second numerator, and 4 over 3 in the third numerator instead of C. And you can see that because you have a linear function down and you have up a constant number, you're going to take a constant outside and there will be 1 instead of it. Exactly, this is what we will have. We wrote A, B, C in their positions. Now, if we're going to take any constant outside, according to the theorems, and this constant outside and that one outside, you will have 1 dx. And 1 is the derivative of x from down. That means we can say that this integration is for ln the denominator because the numerator is a derivative of the denominator. And keep the constant outside as it is. Negative half outside ln the denominator and keep it inside absolute value because ln doesn't accept negatives. A plus 1 over 6. Ln the denominator again, x plus 1 inside absolute value plus 4 over 3 ln absolute value of x minus 2 plus c because our integration is n definite. Now this is what we get from example number 1. Let's go to example number 2. In example number 2, we're going to have the other type of fractions, which is the improper fractions, when the degree of the numerator is greater than or equal to the degree of the denominator. In that case, the first step is you need to divide, make a long division, or use some ways of simplification. And you will get after that a polynomial and a fraction which can be integrated as before, like you learn how to integrate the basic rules of integration or by using any theorem that you studied before. This example is giving you x cubed dx over x squared minus 4. You can see that the degree of a numerator is a 3 and the degree of the denominator is 2, which can be bigger than the denominator. In that case, you should make a long division. Watch it. This is what you will get after you're going to make the long division. This is how you're going to make the long division by making an x cubed, which is the numerator, inside, and x squared minus 4, which is the denominator, make it outside as a divisor. Now divide x cubed, divide by x squared. By subtracting the powers, 3 minus 2, you will get x1, x to the power of 1. Now, according to what you learned before in long division, after you divide, you should multiply x by each. So x times x squared will give you x cubed, it's a plus. And x times minus 4 will give you minus 4x. After you multiply, you need to subtract. In subtraction, you are going to change the signs from positive to negative and from negative to positive. Now, x cubed minus x cubed, try to read it with the new sign, will give you 0. That means these together are going to be canceled. And you will get down plus only 4x because we are dealing with the new sign. And that means the quotient of this division is x. So you're going to write it as a result of this division. And you still have 4x should be divided by x squared minus 4, but because the power of an x is smaller than x squared, so we're going to keep it as a remainder. So this remainder is going to be written as 4x over the whole divisor, which is x squared minus 4. So this is what we did. We divide them and we get a polynomial. This is what we call a polynomial plus a fraction. This is what we call a fraction. And we're going to integrate it like before. Let us see the last answer. This is what we will get. Now to integrate it, we need to integrate each side. The left side including x cube over x squared minus 4, and the other side including x plus 4x over x squared minus 4. The integration of x by adding the power by 1 and dividing by, you will get, after you split this integration for each and take the constant outside as a common factor, you will get from this integration x squared over 2 plus. Here, remember that you have still a fraction. So the first idea you have to put it in your mind is the numerator derivative of the denominator. You found the yes, but there is 2 missing. So you can multiply by 2 up and divide by 2 down. That will make 2x is the derivative of x squared. So this is the rule of len, and you can divide 4 by 2, which is 2. Len the denominator as it is a plus c. This is our lesson for today. Thank you for listening. And if you have any question or comments, please don't hesitate to write it for me. You are welcome anytime to my channel, and I hope you get the lesson. If you have anything you want to say, please write it down. And don't forget to subscribe, do like, and share. Thank you very much again.